This is our second retaining wall example. In this case, we have a cantilever wall, and we're going to calculate the factor of safety against, it says toppling here, but that's really overturning. And we're given information about the retaining wall's density, which is the weight of the concrete. So if we know that our factor of safety against overturning is the resisting moments over the overturning moments. So what is trying to not push it over versus what is resisting. So when we're going to calculate the resisting, the first thing we want to do is find out all the forces that are resisting the overturning. So in that case, we have different sections of our wall here that are going to be resisting from their weight pushing down. And then we also have the soil here that has some overturning resistance, and the soil here that is also overturning. So we're going to label each of these sections. So we'll call this section 1, this section 2, this section 3, and this section 4. And we're going to calculate the weight for each of those sections. So the weight for section 1 is the unit weight of the soil. So it was given as 132 PCF times the area of that soil. So in this case, it's 2 feet by 2 feet. So that is 528 pounds. The second weight is 132, the unit weight of the soil, times its 7, times the height, in this case, was 12. So this is 1 foot wide, so this is only 12 feet for the soil there. So this gives us an area, or a force of 1188 pounds. The third weight is the weight of this portion of the wall. So the unit weight is 150. The area is 1 foot times 12 feet. So that is 1,800 pounds. And the fourth weight is 150 times the area, which is 1 times 10. So that gives us 1,500 pounds. Now that we know where the weight of each of those is acting, we need to know where it's acting. So since all of these are rectangles, we can calculate where they're acting for each of these forces. So in this case, for 1, it's acting in the center. So if we're going to figure out where the overturning is occurring from point A, here's point A, we're going to figure out how far each of these forces are from point A. So from point A, the first force is acting 1 foot away. Force 2 is over here. It's acting in the center of that, and it's acting at 6.5 feet from point A. Force 3, which is center here, is acting at 2.5 feet. And thirdly, force 4, which is this bottom section, it's acting in the center, which is 5 feet. So now that we have the forces, the weights, and the locations from the overturning moment, which is from point A, we can now calculate the overturning moment. So the moment for overturning then is the summations of the weights times their distances. So 528 times 1 plus 11,088 times 6.5 plus 1,800 times 2.5 plus 1,500 times 5. And that equals 84,600 pounds. All right. So now that we know how much resisting force or moment there is, now we need to figure out how much is pushing from the soil. And the soil is going to be pushing on this section here. So we're going to calculate that area. So there's both a passive portion and an active portion. So the passive is acting over here. So this is passive. It's helping resist. And this portion over here is the active. It's what's pushing the wall out. So for the passive force, we're going to need to calculate Kp, times the unit weight times h squared over 2. So in this case, Kp can be calculated as tangent squared 45 plus v over 2, which equals 3.5. And then our unit weight, so this is gamma h squared over 2. So this is 3.5 times the unit weight, which is 132, times the height, which is over here, 3 squared divided by 2. So the passive force is 2,079, and it's 1 foot from A as well. For the overturning, this is the moment resisting overturning. For the overturning moment, that's going to be the active side. So this is going to be the Ka, the active, times the unit weight h squared over 2. So in that case, Ka is tangent squared 45 minus v over 2, which equals 0.285. So 0.285 times 132 times 13 squared over 2. So that's 3,179, and it's at 4.33 feet. So the moment then for overturning becomes 3,179 times 4.33, which equals 13,765. So the factor of safety for overturning then becomes 86679, which is the force that was pushing the over. So that's the sum of these two forces. Over 13,765, which is the toppling moment. And that gives us a factor of safety of 6.3.